Hi grade 10s. Today we are going to look at potential energy. We are going to look at some different types of potential energy and then how to calculate it. So our first two different types of potential energy, first one being elastic potential. So if you stretch an object out, an elastic object, which it changes the shape of it, you actually, store the work you just did as potential energy. So this happens in a bungee cord. If you pull an elastic band to shoot it, all have elastic potential energy. Chemical potential energy is energy that is stored within the bonds of a molecule. So this is what we talked about in our chemistry unit. If you have a combustion reaction, that energy is actually stored within the bonds. And when that combustion reaction occurs, that energy is actually released. So the methane, which you're starting with, has potential energy because it's stored within the compound. Nuclear potential energy is another example. So this is what happens when atoms split apart or decay and energy is released from them. So this often happens when an atom is unstable. So uranium-236 is an example of this. You can split it, and when that atom splits, it releases a large amount of energy and some neutrons, and the neutrons actually collide with uranium-235 atoms, and then they split apart, and then that will actually cause another uranium-235 to split, and it's this chain reaction, and that's nuclear potential energy. Gravitational potential energy is the one that we're going to look at, not in Science 10. We're going to look at what it seems kind of like gravitational potential energy because we're going to deal with gravity. But every object that has a mass has a gravitational field, and it attracts other objects towards itself. But the field that we're talking about is so weak that you only notice it with really large masses. So that's why planets have a gravitational pull towards the sun, because the masses are so large. And you talk about this more as you go up into your physics concepts. So we are looking at, smaller masses of potential energy, but it's still gravitational because we're dealing with gravity. So when we are looking at our formula, this is found on your formula sheet, right here. E stands for energy. That little p is important to include because it's talking about potential. We're going to talk about kinetic soon, and that's going to have an EK. So EP is dependent on your mass of the object, which is in kilograms. Acceleration due to gravity, this is always going to be 9.81 meters per second squared for our reasons, because we're on Earth. And the H stands for height, which is going to be in meters. So, example 1. This is a nicely worked out set example for you. So as I do this example, it says how much potential energy does an 82.0 kilogram man have? So I would say that's my mass. And then it asks how much would it have if that person was standing on top of the Empire State Building, which is 381 meters tall. So I have M, I have H. I always know that G is 9.81. It's non-negotiable unless otherwise told or trying to calculate. And then we plug it into our formula. So notice I write my formula first, then I put my number in for mass. My G is 9.81, and my height is 381 meters. If I type this in my calculator, this is the answer I get. So I am allowed 3 sig digs, 1, 2, 3, 1, 2, 3. So I only get, which means I need to move that decimal into scientific notation. So I want this number to be between 1 and 9, so 3 works. So 3.06 times 10 to the 5 joules is my answer. Okay, example 2. How much potential energy, so EP is my question mark, does a 2.35 gram penny have if it is in an airplane 1.2 kilometers above the ground? So I'm going to pause and think, are these units the what I need them to be? The answer is no. Okay, I need my mass to be in kilograms. So in order to go from grams to kilograms, okay, I need to actually divide by 1,000. So I should get 0.00235 kilograms, because grams is much smaller than kilograms. So that way I know I'm going to divide by 1,000. Now kilometers needs to actually be in meters. And because kilometers is much larger than meters, it means I'm going to end up with quite a few meters in a kilometer. So I'm going to times by 1,000 because kilo means 1,000. So I should get 1,200 meters. Okay. So now I write my formula. EP is equal to mgh. It's not negotiable. You need to write it down. Then we put our numbers in. Almost forgot the 5. 9.81. I like to in units as I go. This is a good habit to establish as you keep going into your sciences, and your height is 1,200 meters. It also reminds you of what your units should be at the end. And if we calculate this out, we should get 27.6642 joules, but I only get 2. There's 3 here. I get the least amount, 1, 2. I only get 2 sig digs. So 1, 2 means the 6 is going to make the 7 round up to an 8. And my potential energy for that penny is 28 joules. Okay, if a plastic cup 1.27 meters off the ground, so meters tells me its height, has a potential energy of 0.0576 joules, what is its mass? Okay, height's supposed to be in meters, potential energy is supposed to be in joules. Looks like I'm good to go with my units. So my formula, this is where we're not just calculating EP, so I'm going to have to do a little bit of algebra in order to solve for this, but it's possible. So EP is 0.0576. Mass is my unknown, so I'm going to leave it as M. G is 9.81 meters per second squared, and H is 1.27 meters. So I like to simplify this first personally. So I'm going to multiply these two together, and that number should end up being 12.4587. Now, this is the math part. How do you get rid of something that's being multiplied? Because I'm solving for M, I'm going to divide. You do need to include all of the decimals when you do this. And if I divide one side, I divide the other side. So my mass, top number divided by my bottom, should give me 0.0046. 2, 3, a whole bunch of other numbers, and mass should be in kilograms. Don't forget my units, but I'm going to do sig digs, so I only get 3, 1, 2, 3. So I'm going to move my decimal 1, 2, 3 places. 4.62 times 10 to the negative 3 kilograms for mass. My last example for potential energy. If an 85.3 kilogram man is on a 10-meter diving board, how much potential energy does he have? Okay, mass is 85.3. Height is 10.0 meters. And you're looking for potential energy. So I'm going to pause, let you try this one, pick an answer, and then you can press play to see how you did. Okay, so depending if you got it right or not, this is your confirmation. So I'd write my formula. My mass is 85.3 kilograms. I didn't have to do any changes to my units. Gravity is 9.81 meters per second. And my height was in meters, which is the appropriate units as well. This means all I have to do is type it in my calculator, and I should get 8,367.93 joules. Significant digits though, I get 3, so 8.37 times 10. I'm going to move the decimal 1, 2, 3 spots until that first number is between 1 and 9. And my units is joules. That is it for potential energy. You'll get kinetic energy next. Bye, guys.